In less than a year since its launch on December 25, 2021, the James Webb Space Telescope has altered the way we view the universe. Multiple images obtained by the largest telescope with arguably the highest infrared resolution and sensitivity have gone viral around the world. The James Webb Space Telescope is without a doubt the most sophisticated telescope in history of mankind. Its Integrated Science Instrument Module, or ISIM framework, provides it with electrical power, a computational framework, cooling capability, and structural stability. The ISIM also houses the telescope's 4 science instruments and guide camera. The wavefront sensor for the observatory is the infrared imager NIRCam, while the NIRSpec performs spectroscopy using the same wavelength range as the NIRCam. On July 12, 2022, the world saw the first images from the telescope, and experts say these images from the world's largest and most powerful telescope show Webb at its absolute best, fully poised to further unveil the infrared universe. Images of cosmic cliffs in the Carina Nebula, exoplanet WASP 06b, the Southern Ring Nebula, Stephan's quintet, and the beautiful deep field view of the universe were among them. However, these were only the first images from the James Webb Space Telescope, which has since presented scientists with far more brilliant and breathtaking images of the cosmos. Some of these images have baffled astronomers and cosmologists. Since the release of the JWST images and data, a torrent of astronomical papers has been published. A couple of these papers have caused cosmologists to panic. But what exactly is causing this wave of panic? The presumption is that the James Webb Space Telescope's findings openly and repeatedly contradict the Big Bang theory. To grasp what is going on, we must first understand what the Big Bang is. The Big Bang has become the most widely accepted cosmological model for explaining the evolution of the observable universe. It originated from observations of the structure of the universe as well as theoretical considerations. It explains how the universe expanded from a dense and hot starting point. This model provides a thorough explanation for a wide range of known phenomena, including light element abundance, large-scale structure, and cosmic microwave background. It is consistent with the Hubble-Lemaitre law, which states that the farther a galaxy is from Earth, the quicker it moves away from it. The hypothesis depicts an increasingly compressed cosmos preceded by a singularity in which space and time cease to exist. According to comprehensive calculations of our universe's expansion rate, the Big Bang singularity occurred approximately 13.787 billion years ago, plus or minus 0.02 billion years ago, which is also the approximate age of the universe. The notion of the Big Bang is rather simple and easy to understand, but the name is considered quite misleading for the expanding universe because it conveys the idea of a firecracker exploding at a specific time and place with a center, whereas the infinite universe is actually expanding into itself and the universe does not have a center. The Big Bang truly occurred everywhere at once. It was a process that occurred in time rather than at a specific point in time, as evidenced by galaxies rushing away from each other rather than from a single central point, and we see the heat left behind from these early times that uniformly fills the universe. And as much as we'd like to, we can't see the Big Bang, but that doesn't mean there isn't observable evidence of it. Scientists believe that we could detect the heat that existed approximately 380,000 years ago. This heat covers the whole sky and fills the cosmos around us. The Cosmic Background Explorer, Wilkins Microwave Anisotropy Probe, and Planck satellites were used by NASA and the ESA to map it out. The universe was extremely smooth at this epoch, with only minor temperature fluctuations. The JWST was designed to see a period of the universe's history that we had not seen previously, rather than the beginnings of the universe. Planck, the Cosmic Background Explorer, and the Wilkins Microwave Anisotropy Probe have all seen farther back than the James Webb Space Telescope. The James Webb Space Telescope's primary goal is to image the first objects that were created as the cosmos began to cool following the Big Bang. That time period is perhaps hundreds of millions of years later than the one the other satellites were built to see, says Dr. John Mather, lead project scientist for the James Webb Space Telescope. Dr. Mather believes that the tiny temperature ripples observed by these satellites were the seeds that grew into new galaxies. What humanity does not know is when and how the first stars and galaxies formed in the universe, and this is the question that the James Webb Space Telescope was built to answer. To sum it up, the Big Bang Theory is the leading explanation for how the universe started. In its most basic form, it states that the universe as we know it began with an infinitely hot and dense single point that inflated and expanded at unthinkable speeds at first, and then at a relatively measurable rate over the next 13.8 billion years to the still expanding cosmos we see today. So far, the Big Bang hypothesis has been our best bet for the origins of our universe, but fresh images from the JWST appear to be casting doubts on its legitimacy. Most cosmological theorists have supported the Big Bang idea as an irrefutable reality for decades, but fresh data from the JWST is causing those like Alison Kirkpatrick to panic. She is an astronomer at the University of Kansas in Lawrence, and the recent disclosures have caused her to rethink whether everything she has done in the area is wrong. According to a few experts, the relatively small, smooth, old, and shockingly abundant galaxies are absolutely incompatible with the Big Bang idea. According to the Big Bang theory, the universe is expanding, and a bizarre optical illusion must exist in outer space. Galaxies and other objects in expanding space do not continue to appear smaller with increasing distance. Instead, they begin to grow larger as their light is thought to have left them while they were close to us. However, the JWST images show them getting smaller and smaller. Even galaxies with much higher brightness and mass than our own Milky Way appear 2 to 3 times smaller in these images, suggesting that the universe isn't expanding and the redshift isn't proportional to distance. According to Eric Lerner and Riccardo Scarpa, the redshift of the newer galaxies in the images is 2 to 3 times greater, which significantly defies the concept of an expanding universe. However, it is consistent with their claim that we are part of a non-expanding cosmos. They had previously published conclusions based on Hubble Space Telescope images showing galaxies with redshifts ranging from 1 to 5, which correspond to the expectations of non-expanding ordinary space. They were certain that the James Webb would only confirm their suspicions. Big Bang theorists expected to see terribly mangled galaxies jumbled by repeated collisions and mergers, but the JWST images revealed overwhelmingly smooth disks and orderly spiral shapes like to what we detect today. The results in the Panic article suggest that there were almost 10 times more smooth spiral galaxies than projected, which calls into question our assumptions regarding merging as a common occurrence. Lerner and Scarpa contend this data completely demolished the merger theory. According to the Big Bang theory, the most distant galaxies in the James Webb data are viewed as they were 400 to 500 million years after the birth of our universe. However, some galaxies contain star populations that are at least 1 billion years old. The existence of these galaxies, according to the authors of the Panic article, is proof that the Big Bang did not occur, and just as there must be no galaxies older than the Big Bang, theorists presumed that as the JWST looked out further in space and time, the galaxies would become too few and ultimately there would be none left, indicating a dark age in the cosmos. However, a paper that has yet to be published shows that galaxies as massive as the Milky Way are common even a few 100 million years after the theorized Big Bang. From the Big Bang standpoint, faraway galaxies are assumed to be intrinsically smaller. One galaxy mentioned in the papers is GHZ2, which is far more dazzling than the Milky Way, but is only 300 light-years in radius. This is 150 times smaller than the Milky Way, and the JWST images are not the sole reason the Big Bang theory may be incorrect, according to Lerner, who believes that the Big Bang theory now makes 16 incorrect predictions and only 1 valid prediction. Its helium prediction is wrong by a factor of 2. The projection for lithium abundance is 20 times off. In addition to the abundance of greater and more distant optical illusions, there are large-scale structures that could not have evolved in the period since the Big Bang. The majority of cosmologists and astronomers have claimed that there is an explanation for every question highlighted by Lerner and Scarpa's article. The Big Bang theory is not dead, and subsequent JWST discoveries have not disproven it. These observations have revealed some surprising and unusual features about the cosmos, but that's all. The Big Bang is based on two facts. First, more distant galaxies have a higher redshift than nearby galaxies, and second, the cosmos is filled with a cosmic background of microwave radiation. These are two of the three data pillars supporting the Big Bang theory, with the third being the relative abundance of elements in the early cosmos. However, they are only the model's foundation. In recent years, scientists have improved on these to construct the standard model of cosmology, often known as the LCDM model. This model supports everything from the acceleration of cosmic expansion to the clustering of galaxies. The Tolman test anticipates that if the universe were non-expanding and static, the surface brightness of all galaxies would be the same, irrespective of their distance, which isn't the case as evidenced by the JWST images, which show that distant galaxies have a dimmer surface brightness than closer ones. It's a popular misunderstanding that redshift proves galaxies are speeding away, but it doesn't. Distant galaxies aren't rushing across space, rather space itself is expanding, placing more distance between us. This minor distinction underscores that galactic redshift is caused by cosmic expansion rather than relative motion. Experts aren't disputing that what the James Webb Space Telescope discovered does not exactly match their expectations, but scientists were hoping to uncover this type of perplexing evidence. They feel that is why so much money was invested in developing the James Webb Space Telescope in the first place, and they accept that the data acquired by this amazing telescope does not prove that the Big Bang model is incorrect, but some of their assumptions about it may be incorrect. Do you think Lerner and Scarpa's theory of the non-expanding universe has merit? Tell us in the comments section below.